this video, we'll go over a couple of examples of where you could use finding the vertex for some application. There's also some videos on my website that show some more visual examples. Alright, so if we take a look at the first one, it says, a ball is tossed upward with an initial velocity of 30 feet per second from a height of 6 feet. The height of the ball, t seconds, so we know that t represents the seconds, after it is tossed up is given by f of t. It says, what is the maximum height? So that's what we're trying to find. What is the maximum height of the ball? And, so we're finding two things, and when? So we're finding t as well. When will it reach this height? Round your final answer to the hundredths if necessary. So in this problem right here, it asks us, so we have a basketball. It's going to go up. It's going to go through the net and come back down. And it wants to know what is the maximum height. So if we just draw a picture and think about it, the maximum height, if the ball's going up, it's going to finally reach a high point, like right here, and then it's going to go back down. So what we call this high point right here is the vertex. So what the problem is really asking us is to find the vertex. So the formula we learned for the vertex is when we want to find the ordered pair for the vertex, and we have x and then we have y. But in this problem, instead of x, we have t. So instead of negative 16x squared, like we're used to seeing, instead of x, it's t. So normally to find x, we do negative b over 2a. So again, instead of x, the variable in the problem is t. So that's why I'm putting a t here. So then a is negative 16, b is 30, and c is 6. So we're going to go ahead and plug in the 30. So negative 30 over 2, and then for a, it's negative 16. So we have negative 30 divided by negative 32. It says round final answers to the hundredths if necessary. So if we do negative 30 divided by negative 32, we would get 0.9375. So it says to round to the hundredths place. So 100 hundredths has 2 zeros. So that reminds me I need to circle two numbers after the decimal. And I look to the next number, and if it's 5 or higher, I make the 93 94. So it's about 0.94. So it says the maximum height is, well, what we just found was t, the seconds. So again, t, it says, is the second. So that's how I know it's about 0.94, about 0.94 seconds. So in less than 1 second, it's at the highest in this situation here. So now if I want to find what the height is, that's what this side of the equation is. So instead of y, it's f. Okay, so we're going to go ahead and plug in for t, 0.94. So for all the t's, we put 0.94 in. And then we do this in order of operation using our calculator. So we would have negative 16 times 0.94. So that's negative 15.04. And then 30 times 0.94 is 28.2. And then we're just going to add all of this up. Hold on, let me add that again. Oh, I just realized this is squared right here. So I didn't bring down the squared. So I'm going to go ahead and do this part again. So 0.94 squared is 0.8836. and then times negative 16. So this should be negative 14.1376. So it does say round to the hundredths, but it says final answers. So we're not rounding here until the very end. So then we're going to combine all of this together, and we get 20.0624. So again, it says to round final answers to the hundredths. So that's two numbers after the decimal I have to circle, and I look to the third number. It is not 5 or higher. So I put the maximum height is about 20.06, and it's measured in feet. So feet. Okay, so again, in any kind of application problem where you have a quadratic, so a parabola where something needs to go up and then something needs to go down, if ever it's asking you to find the highest, that's how we know what to do, how we know when to find the vertex. If it asks us when will the ball reach the ground, then we're not doing this. Then we're setting the equation equal to 0 because the height is 0. So especially in this chapter, you want to read the word problem and see what it's asking you. Okay, so let's go ahead and take a look at the next application problem. So it says the monthly revenue in thousands of dollars. So whenever I get the revenue, I need to label it in thousands of dollars from selling X hundred computers. Okay, so X is the number of computers in hundreds. So if I get 10, it's not 10, it's 1000. If I get 4, it's 400. Is given by how many computers, so I need to find out how many computers, that's what I'm trying to find, must be sold to maximize the revenue. So it wants me to find how many computers and the highest revenue. So in this problem right here, the leading coefficient's negative. So I know something, or that the shape of this graph is going like this. So since this is talking about the amount of money that they've made off of computers, it looks like, imagine that the profit's going up, or the amount they make is going up, right? And then if they sell the computers for too much, then they might lose money because less people are going to buy it. So that's why the shape of graph could make sense in a particular situation like this. So you want to figure out, what's this sweet spot right here? How much should they sell the computers that they'll make the most profit, because then it gets too expensive so people won't buy them. So since it's asking us for the maximum, that is called the vertex. If we want to find the highest amount of money that they can make to sell the computers, that's called the vertex. So again, this is X and this is Y, and in this problem, it is still X. They used X. So if we want to find X of the vertex, it's negative B over 2A. So A is negative 2, B is 40, and C is 235. So we're going to have negative 40 over 2A, and we get 10. So X equals 10. Okay, so now we're going to go ahead and plug 10 in for X to find what that profit would be, or that revenue would be. Okay, so order of operations, 10 squared is 100, and then times negative 2. And then we multiply. And then we combine all of this together, and we get 435. Okay, so X represented 100 computers. Well, the number 100 has 2 zeros. So I need to either think of this like I'm going to take 10, and I'm going to multiply by 100 because it's in hundreds computers. So we would get 1,000. So the number of computers to sell is 1,000. Or because 100 has 2 zeros, you know you need to add 2 zeros. So that's why 1,000 computers, the number of computers to sell is $1,000 to reach a maximum profit of, so we have 435, and it's in thousands. And thousands has 3 zeros. So that's how I know either you're going to multiply this by 1,000 because it says it's in thousands, or you're just going to add 3 zeros to this. So 435,000. So again, it says the monthly revenue in thousands of dollars from selling X hundred computers is given by. So again, the amount of revenue is going to peak up and have a maximum, and then it's going to go down. So this is the most profit they'll make if they sell 1,000 computers. And then they're probably going to sell it for too much, and the profit will go down. Okay. So again, there's lots of other examples that of where we want to find the highest point or the maximum or the minimum. These are just 2 examples. So when you do your homework, you'll do a few other examples as well.